enough if you just stop your video?
Hi, everybody.
Hello.
I don't. Are we public?
We are live, Bill. Yes.
I think we're live.
So I'm looking for the session, but there's a delay. So okay, so we have a number of questions canned, but we'd really like to take new questions. So if you could put any of those in the chat, it would be good. So I see questions on whether Pocket Beagle is upstream, but I don't think that's a question for this session. There was some talk about how good it would be for system Devicetree on things like TI's AM64 that's got lots and lots of cores. I think the stuff that Stefano talked about and Kumar talked about marry very nicely together, and so that's something that's pretty interesting.
Yeah, so, and I think that is really one of the big use cases for system Devicetree, right? That you have, and from a science point of view, that's why we've been really interested in it, because we have all these different devices, and then we have the programmable logic where people put in their new both peripherals and soft cores, so new CPUs just pop up, right? So we need a way to have a flow where you can have one true source. So it's definitely a good use case.
Yeah. So if we don't have a question, I have a question for Kumar, which is, so right now you're talking about code generation in Zephyr. Has there any, but Zephyr is also being ported to Cortex-A's and things like that have more space. Is there any talk about doing, bindings for Zephyr so that, it could take a Devicetree at runtime?
Yeah, there's been some interest that's been shown kind of around that. I think there's some interest actually from NXP, and they've been doing some work around using Zephyr with Jailhouse on a Cortex-A, I think 53 based SoC, and so I think it's still I'll call it in conception stage, because I think it's kind of trying to figure out how a runtime DT model would sort of work in having someone kind of sketch out or prototype a little bit of what that would look like compared to kind of how the driver model and device model works in Zephyr right now, being very kind of static driven in a sense of being, from the, code generation perspective. And so how you would marry those two is something that I think someone needs to kind of think about or look at that's wanting to drive that. But I don't think there's, like most any open source project, if someone's interested in contributing work in that area, then that would be something. But I don't, it's kind of the question of what additional value does something like that get, where if you have a DTS and you're going through one other build stage of getting code generation out versus having a blob, and so forth. So just kind of understanding kind of what's needed there.
Good. So Stefano, obviously one big question, we talked about it a bit in our session about, Devicetree versus ACPI. Servers and more standardized environments are definitely going ACPI. You and I had talked a little bit about generating ACPI tables directly from system Devicetree. Can you talk about that idea a little bit more?
Well, so the idea is on a system where an heterogeneous system with a large CPU cluster and one operating system on that large CPU cluster want to use ACPI. The configuration, I will imagine, the description of the full board will still be system Devicetree. You will still get a traditional Devicetree, maybe for your Cortex-Ms, for your Cortex-Rs. That doesn't change. If you have a static hypervisor like Zen or JLouds or others, you will still get maybe a device tree for each of your partitions. But then eventually it goes down to that one operating system, which could be Linux, could be Windows or other that support the CPI. Then we will need that translation, from the traditional device tree for that OS to a CPI. And that has been done a few times in the past, like a few projects have done that, from firmware projects to QEMU even. So it's known to be possible, maybe not straightforward, but definitely doable and maintainable as well. Because most of ACPI, some of the ACPI is actually static as well, so that can be easily generated. And the difficulties are the bytecode interpreted part of the CPI, but even that can be done, especially if you have powerful build-time tools at your disposal.
So Grant, we talked about how Devicetree intersects system-ready IR.
Yep.
What is? I know there's several sessions at Connect about system-ready. Can you bridge those gaps a little bit for this session?
Mm-hmm. Yes. So we've got the larger system-ready program, which is certification for across a wide variety of ARMS devices. And in the server, when we did server ready, that was ACPI and UEFI. But for one of the new bands of system ready, which is IR, targeted at the embedded devices, we've chosen Devicetree for that one. And the reality, like the pragmatic reality, looking at the market, is the embedded Linux ecosystem is different from what's required in server. And right now, all the SOCs already support Devicetree. It is mature, and we have a way of supporting that in the distros or within Linux, and also BSD for that matter. So Devicetree is what works. It makes sense to keep supporting. It's not going away anytime soon. So the effort with System Ready on the IR band is to standardize that. How that fits in with the larger System Ready is that wherever possible, we're trying to use the same standards across the System Ready bands. So if you take a look at what the standard says, the specs say, is that the IR band, the ES band, the SR band, all of them use UEFI as the API to the OS, so that the OS knows how the platform is going to perform, it knows how to boot. But then when you talk about the system description, for embedded compute, for edge, embedded edge IoT, that's all Devicetree. For ES and SR that are targeted at the shrink-wrapped OSs, so if you care about Windows or you care about VMware ESXi, well, then that's ACPI. Which one you use depends very much on which operating system target your product is for. And from the OS point of view, an OS can support both. So if you're talking about Linux, if you're talking about BSD, those OSs support both. And a Linux distro can land on either a Devicetree-based system or an ACPI system. It is perfectly happy to support both if the distro is happy to do that. So we've got a story with System Ready that covers all those bands, but deals with the particularities of the embedded compute and how it's different from servers.
So Thomas, Xilinx has been a big supporter of the system device tree concept. What motivated you to start this work?
Well, as I mentioned a little bit before, our problem is that we have really heterogeneous parts, and we have devices that show up on the fly because we can reprogram the hardware and so on. And so we had some internal tooling that could create some device trees out of our EDA tools and so on. But it was all proprietary. It worked on on R Linux. but our customers, they're using various operating systems, RTOSes, and they're mixing them. And for example, VxWorks is popular, right? It didn't work for that. For bare metal, we had a special way of translating. And so we were thinking we really need to standardize this thing, and it shouldn't really be a siling standard. So really interested in working with other people. So instead of coming up with a new standard, our stuff was based on XML and things like that. So let's see if we can work with device trees. And so what we're hoping is that RTOS vendors, other SoC vendors, whether it's for the firmware, for hypervisors, for RTOSes, and so on, really adopt device trees as their way. And then system device tree can provide one true source, as we call it, so that you only have to, if you want to share a page, for example, for Vert.io, you specify that in one place and it just flows through it. And that's one of those things that our customers, they complain the most about, is that it's so darn hard to configure our systems, because you miss one thing in one place and pound define somewhere, and then the system doesn't work, and it's really hard to debug that stuff, right? So what we hope as well is to add verification into it, so you can see that the RTOS and the Linux has a consistent view of the resources, as opposed to, you know, you put in something here and then after a while it turned out that both were trying to use the same device at the same time.
Great. Grant, do you want to talk about EVPR on other architectures?
Yeah, I answered on the chat, but so EVPR, for those not aware, it is a publicly maintained spec. It is on GitHub. It is a community spec. It is not one, even though I'm the maintainer of it, we don't view it as being owned by ARM. Right now it specifies how to do the standards on ARM platforms, but it is absolutely open to any other architecture. The RISC-V folks have been involved a little bit. I don't have any patches yet that can be merged to bring in RISC-V support into the document, but I'm absolutely supportive of it. I think this is one of the areas where having different documents for us in the Linux ecosystem, it doesn't do any good. I mean, what I'd like to see is we use common interfaces regardless of the architecture. I would rather compete on technology and products rather than competing standards where then in the Linux ecosystem, we then have to figure out how to deal with each of them.
Great answer. So Louis, what challenges does ST see with Devicetree?
Well, there are several. First, I would say that we are following the system Devicetree initiative proposed by Xilinx because we have exactly the same issues. Devicetree is used by all our software components running on SM32 in P1, on Cortex-A, but also on Cortex-M4 with Zephyr. And we have some consistency issues between the different software components. So having, like you mentioned before during the video, one locations for all Devicetree was one possible solution to have one, I would say, unique source for the DTS files, but it was not possible. So you mentioned some tools that are proposed to maintainers to manage the consistencies, but system Devicetree is another answer. That means that we'll have one unique way to define all the systems, the configuration of the systems, and to generate a consistent configuration for all the software components. Second challenge will be, as from my point of view, the Devicetree life cycles. How to update part of the system configurations thanks to update over the year, still having a consistent configuration between the different software components. So today on ST platform, for example, we have several DTB, one per software component, but with the discussions we have ongoing with system ready specifications where we have one unique hardware descriptions, is how to maintain a consistent hardware configurations for all the software components running on the platform. And I think that there is a lot of things to do here. You mentioned the Devicetree signatures also, how to verify the Devicetree we are using in the secure boot. So all this, for me, as a net challenge for the Devicetree.
Great, thanks. So Andre, with WinRiver, you know, you're integrating a lot of these solutions from different SOC providers, and you talked a little bit in your video about some of the challenges that brings up. What is WinRiver specifically doing around Devicetree?
Yeah, I think it's first of all interoperability, right? So, and as we have discussed before, and Thomas also has pointed out, so that there are we do support in VxWorks Devicetree, which is a little bit different from like with some specific extensions. But Thomas has mentioned that other operating systems, real-time operating systems, does not support it at all, right? And then it would be good to have some kind of, you know, interoperability where you could or where users at the end or system integrator can easily exchange the components depending on their needs, right? And still have consistent device tree or system device tree across the whole platform, right? So, and we are working on VxWorks in this area to make our device tree compatible with other stuff. Yes, so.
Great.
Can I ask a question on that? Have you found a lot of pain points on compatibility when compared to the device tree that is in the Linux kernel? Do you try to maintain compatibility there, or does what Linux uses for a device tree end up differing from what you are using for VxWorks?
Yeah, but basically what we have done recently, yeah. So we have decided to make our device tree compatible with the Linux one, right? So to have interoperability there, and I think it's good for the moment.
Yeah, this is one of the things.
At least on the operating system level, right? So at the operating system level.
Yeah, because this is one of the areas that I'm concerned about. Or I mean, we've talked about device tree stability for many years on how to get stability between different kernel versions. For system ready, where the platform provides the device tree, that becomes even a bigger concern. I'm hoping that with the increased level of testing, that will actually help with stability. But I do think that that's one of the challenges for device tree that I don't feel like there's a really strong solution for.
So just one point on that one, I totally agree with you. As part of this, we need more standardization, how things look like. And that was one of the things when we were talking about remote proc and sort of sharing the pages. It turned out that everyone had their own way of describing all those things, and there was mailboxes, how you name those, and so on. So the long-term plan, of course, should be that let's standardize on that so it doesn't look different. But a sort of half kludgy but still very workable way that we're doing right now is that you align on how you specify it in the system device tree, and then you have a little plugin in Lopper that takes care of all the icky details that each device vendor has. And it's not the best approach, but it's much better than the alternative that you have to do. So that's one way to go forward while we are. It always takes a little bit longer to sort of do the standardization we all want.
Great. So in the meantime, Drew, thanks for the good questions, Drew. So Drew's been asking about overlays. So it's, as I reported in the session, there is work to get the device tree overlay source files accepted upstream, but that is still for being applied at by the bootloader. Frank has your question was going to be my hard question to Frank, but unfortunately he can't be live here. So Frank has given some good answers there and this is something that will continue to go forward. But from a kernel maintainer point of view, Rob, what challenges do you see what are you working on for Devicetree maintenance?
Can I answer the overlay part first?
Sure, that would be great.
So the basic infrastructure has gone in for 5.13, which allows us to build overlays and also apply overlays at build time to verify it, which will allow us, if we have existing DTs that we want to split into a base plus overlay DT, we can do that and keep the original complete DT. As far as runtime management, I think Frank's link probably covers that the best, but we already support runtime applying, and with the FPGA manager subsystems supports that already and has for a number of years. So to your question on maintenance for DT in the kernel, most of that right now is working on getting DT schema in place. There's about 4,000 bindings in the kernel tree, and we're, I think, at somewhere over 1,000 or schema now. So that's getting worked on, and as we get more and more schema in place, there's additional things we can do, and like verification that binding is documented.
Good.
Yesterday, I saw one colleague of mine gave me the first patch series to add overlay support for Xen 2. Because, obviously with FPGA, if you add something new, you need to let also the hypervisor know it's not an OS only issue. So we'll get there as well.
Interesting.
So I see another question from Drew. Should I start sending patches to add overlays? The answer is it depends on the subarch, I think, at this point. So one of the dependencies for 32-bit ARM, and the subarch needs to split out the DTs to a subdirectory, which we did for ARM 64, but not on ARM 32. Because right now we have a single directory and it's thousands of DTS files, and it's become unmaintainable, I think, with adding overlays there.
Yep. But yeah, so Drew, I think BeagleBone capes would be a great driver use case for that overlay support. So, so there's a little bit of talk about the new FDT format. So this is an active discussion in the Devicetree evolution calls that we have every 2 weeks on Mondays. If you're interested in this topic and are interested in not just watching, but participating in the conversation, that would be really good to get some other people in that call. So if you subscribe to the Boot Architecture mailing list at lenaro.org, that's where we announce that meeting.
Hey, Bill, it looks like in 14 seconds this may shut down.
Yeah, that was the last thing I wanted to say. So thanks, everybody, for participating.
Thanks all.
Thanks. Bye.
Thanks. Bye.